Welcome to What's New in the upcoming Apache Spark 3.0 release. My name is Denny Lee, and I'm going to be your host today for our OSS Engineering Manager, Xiao Li from Databricks. We're going to dive deep, so please do have lots of great questions. Use the chat session below to ask your questions, the Q&A session, excuse me, as well. Once the session's over, we're going to have a live Q&A where both myself and Xiao Li are going to go ahead and answer your questions as well. The slides and the notebooks that we're using today will be made available shortly after the session. So, without further ado, let's go start the session.
Hello everyone, I'm Xiao Li. Today I'm excited to share with you the new features available in the Spark 3.0. First, let me introduce myself. I'm an engineering manager that leads open source development in Databricks. I'm a Spark committer and a PMC member. Previously, I was an IBM master inventor. I got my PhD from the University of Florida, so that is why my GitHub ID is DataSmile. Databricks provides a unified data analytics platform to accelerate your data-driven innovation. We are a global company with more than 5,000 customers. Various industry, we have more than 450 partners worldwide. And most of you might have heard of Databricks as the original creator of Spark, Data Lake, Flow, and Coalesce. So these open source projects that are leading the innovation in the field of data and machine learning. So we continue to contribute and nurture these open source communities. In Spark 3.0, the whole community resolved more than 3,400 JIRAs. Spark SQL and the core are the new core modules, and all the other components are built on top of Spark SQL and the core. Totally, the pull requests for Spark SQL and the core constitute more than 60% in the Spark 3.0. In the last few releases, the percentage keeps going up. Today, we'll focus on the key features in both Spark SQL and the core. This release delivers many new capabilities, performance gains, and expanded compatibility for the Spark ecosystem. So this is a combination of a tremendous contribution from the open source community. It is impossible to discuss all the new features within 45 minutes. I would like to present some of them today. First, let me talk about the performance-related features. In this release, we introduced a new framework of adaptive query execution and a new runtime filtering for dynamic partition pruning. And also, we greatly reduced the overhead of query compilers by more than half, especially on the optimizer overhead and the SQL core and cache synchronization. Supporting a complete set of trunking is another useful feature many people are waiting for. Adaptive query execution was available at the previous releases. However, the previous framework has a few major drawbacks. Very few companies are using it in their production systems. In this release, Databricks and Intel worked together, redesigned the new framework, and resolve all the known issues. Let us talk about what we did in this release. Michael Umbers is the creator of the Spark SQL and also the Catalyst optimizer. In the initial releases of Spark SQL, all the compiler rules are heuristics-based. To generate a good query plans, the query optimizer needs to understand the data characteristics. Then in Spark 2.x, we introduce a cost-based optimizer. However, in most cases, data statistics are commonly absent, especially when the statistics collection is even more expensive than the data processing itself. Even if the statistics are available, the statistics are likely out of date. Because of the storage and compute separation in Spark, the characteristics of the data arrival is unpredictable. The costs are often misestimated due to the different deployment environments and the black box user-defined functions. we are unable to estimate the cost for the UDF. Basically, in many cases, Spark Optimizer is unable to generate the best plan due to these limitations. For all these reasons, runtime adaptivity becomes more critical for Spark than for traditional systems. So this release introduced a new adaptive query execution framework. The basic idea of the adaptive planning is simple. We re-optimize the execution plan using the existing rules of the optimizer and planner after we collect more accurate statistics from the finished plan nodes. This release includes 3 adaptive features. We can convert the submerged join to broadcast hash join based on the runtime statistics. We can shrink the number of reducers after over-partitioning. We can also handle the still join at the runtime. And today, I will explain them one by one. Maybe most of you already learned many performance tuning tips. For example, to make your join faster, you might guide your optimizer to choose a broadcast hash join instead of a submerged join. You can increase the threshold Spark.SQL, the Autom broadcast join threshold, or use a broadcast hash join hint. However, it is hard to tune. You might hit out of memory and even get the worst performance. Even if it works now, it is hard to maintain over time because it is sensitive to your data workloads. You might be wondering why Spark is unable to make the best choice by itself. I can easily list multiple reasons, like what we said before. The statistics might be missing or out of date. The file is compressed, and the file format is a column-based often. So the file size does not represent the actual data volume. And also the filters could be complex. They might also contain the black box UDFs. And the whole query fragments might be large and complex. It is hard to estimate the actual data volumes for Spark to make the best choice. This is an example to show how A2E converts a submerged join to broadcast hash join at the runtime. First, execute the leaf stages in a query, and then collect the statistics from the shuffle operators, which materialize the query fragments. You can see the actual size of stage 2 is much smaller than the estimated size, reduced from 30 megabyte to 8 megabyte. So we can re-optimize the remaining plan and change the join algorithm from the submerged join to broadcast hash join. Another popular performance tuning tip is to tune the configuration spark.sql.shuffle.partitions. The default value is a magic number 200. Previously, the original default is 8. Later, it was increased to 200. I believe no one knows the reason why it is 200. And it's also very hard to tune it, to be honest. Because it is a global configuration, it is almost impossible to decide the best value for every query fragment, especially when the query plan is huge. If you set it to very small value, the partition will be huge. And aggregation, sort might need to spill the data to the disk. If the configuration value is too big, the partitions will be very small. But the number of partitions is big. It will cause inefficient I/O, and the performance bottleneck could be the task scheduler. Then it will slow down everybody. Also, it is very hard to maintain over time. A2E can solve it in a smart way. We can first increase the initial partition number to a big one, and after we execute the leave query stage, we can know the actual size of each partition. Then we can automatically coalesce the nearby partitions and automatically reduce the number of partitions to a smaller one. This is the example. One more popular performance tuning tips is about data skew. Data skew is very annoying. You could see some long running or frozen tasks and a lot of disk spilling and very low resource utilization rate in most nodes and even out of memory. Our Spark community might tell you many different ways to solve such a typical performance problem. You can find the skew value first and then rewrite the query to handle the skew values separately. And also you can add the actual skew key that can remove the status skew, either new columns or some existing columns. But anyway, you have to manually rewrite your queries. This is annoying and sensitive to your workloads, which could be changed over time. So this example, without skew optimization. Because of data skew, the shuffle partition A0 will be very large. If we do a join on these two tables, the whole bottleneck is to join the values for this specific partition A0. So every other partitions just wait for this to complete. A2E can handle it. Yeah, after executing the leave stage 1 and stage 2, we can optimize the query with a skew shuffle reader. Basically, it will split the skew partitions into smaller sub-partitions. So this is the idea to solve the previous data skew examples. It will automatically split the partition A0 to 3 segments and then duplicate another site B0. After this, we can parallelize the handling of this big partition. We can avoid the long running task for A0. And overall, it will be much smaller, much faster now. Based on a 1 terabyte TPS benchmark without statistics, Spark 3.0 can make Q77 8 times faster and also achieve 2 times speed up for Q5 and more than 1.1 times speed up for another 26 queries. So this is just a beginning. In the future releases, we'll continue to improve the compiler and introduce more new adaptive rules. The second performance feature I want to highlight is a dynamic partition pruning. So this is another runtime optimization rule. Basically, dynamic partition pruning is to avoid partition scanning based on the query results of the other query's fragments. It is important for star schema queries. We can achieve a significant speed up in the TPS queries. So this is the number. In the TPS benchmark, 60 out of 102 queries shows a significant speed up between 2 times and 18 times. So it is to prune the partitions, the join raised from a fact table T1 by identifying those partitions that results from the filtering the dimension table T2. So let me explain this example step by step. So this is query. After Catalyst Optimizer, we'll generate this tree. Project, join, filter, scan. First, we'll do the filter pushdown in the left side. And on the right side, we can generate a new filter for partition column PP because the join key is the partition columns. Then we can get the query results of the left side by executing this fragment. And we can reuse the query results and generate the list of constant values, DPP filter results. Now we can push down the in filter in the right side. So this will avoid scanning all the partitions of the huge fact table T1. Now we only scan the very small set. For this example, one runs it in the notebook. So we can avoid scanning 90% of partitions. So with this dynamic partition pruning, we can achieve 33 times speed up. So the last performance feature is join hints. Join hints are very common optimizer hints. It can influence the optimizer to choose the expected join strategies. Previously, we already have a broadcast hash join. In this release, we also add the hints for the other 3 join strategies: submerge join, shuffle hash join, and shuffle nested loop join. Please remember, this should be used very carefully. It is difficult to manage the hints over time because it is sensitive to your workloads. And if your workload patterns are not stable, the hints could even make your query much slower. Here are examples how to use these hints in the SQL queries. They also can do the same thing in the Dataframe APIs. When you decide the join strategies, I list a difference here. Broadcast hash join that requires one side to be very small, and no shuffle, no sort, so it is very fast in most cases. And the shuffle hash join that needs to shuffle the data but no sort, can handle large tables, but will still cause like out of memory if the data is skewed. The submerge join is much more robust, can handle any data size, and needs to shuffle and sort the data, and slower in most cases when the table size is small, especially compared with broadcast hash join. And the shuffle nested loop join, this one doesn't require join keys, different from the other 3 join algorithms. Yeah, so this is some basic information I'm going to share with you when you use the hints. Please be very careful. To enable new use case and simplify the Spark application development, this release also deliver new capabilities and enhance existing features. So let us first talk about the Accelerator-aware Scheduler. In 2018 Spark Summit, Reno announced the new project, Hydrogen. Accelerator-aware Scheduler is a part of this project. It can be widely used for accelerating the special workloads. In this release, we already support a standalone, young Kubernetes scheduler backends. And so far, users still need to specify the required accelerator results using the application level configurations. In the future release, we might support the lower level, like the jobs, stage, and the task levels. In this release, we also introduced 32 new built-in functions and add higher order functions in the Scala API. Among these built-in functions, a set of map-specific built-in functions like transform key, transform value, map entries, map filter, map zip width, yeah, are added for simplifying the handling of the data type map. Pandas UDF. So this is a pretty popular performance features for the PySpark users. So let us talk about the history of UDF support in PySpark. In the first release of Python support, 2013, we already supported the Python Lambda functions for the RDD APIs. Then in 2014, users can register Python UDF for Spark SQL. Starting from Spark 2.0, Python UDF registration becomes session-based. And next year, users can register and use Java UDF in Python API. And in 2018, we introduced Pandas UDF. In this release, we redesigned the interface for Pandas UDF by using the Python type hints and add more types for Pandas UDF. To address the complexity in the old Pandas UDF, from Apache Spark 3.0 with Python 3.6 and above, Python type hints such as pandas.series, pandas.different, tuple, and iterators can be used to replace the new Pandas UDF types. Let's give examples. In Spark 2.3, we have a starter UDF. The input is a pandas series, and the output is also pandas series. In Spark 2.0, we do not require the user to remember any UDF types. You just need to specify the input and the output types. In Spark 2.3, we also have a group map pandas UDF. So this, the input is pandas different, and the output is also pandas different. So this slide shows the difference between the old and the new interface. The new one is much easy to remember to use. The same here. The new interface can also be used for the existing group aggregate pandas UDF. In addition, the old pandas UDFs were split into two API categories: pandas UDF and the pandas function APIs. You can treat pandas UDF in the same way that you use other PySpark column instance. For example, here's calculate value. You are calling the pandas UDF calculate. We do support the new pandas UDF types. Here is shows the examples. From iterator of series to iterator of series, and from iterator of multiple series to iterator of series. And this is useful for expensive state initialization of your pandas UDF, and also useful for pandas UDF pipeline. However, you cannot use the pandas function APIs with this column instance. Here are these two examples: map pandas function API and the tool group map from pandas UDF API. These APIs are newly added in this release. For more information, you can read the blog post published in Databricks website. It introduced a new type hints interface for the pandas UDF, and also this gives some example for this new pandas function APIs and the pandas UDF types. This release also includes many enhancements that makes monitoring more comprehensive and stable. And the efficient enhancements do not have a high impact on the performance. So let us first talk about the new API, new UI for structured streaming. Structured streaming was initially introduced in Spark 2.0. This release adds a dedicated new Spark UI for inspection of these streaming jobs. The new UI offers two sets of statistics, aggregate information of completed streaming query jobs, and detailed statistics information about the streaming query, including input rate, process rate, input rows, batch duration, operation duration. We also have many different enhancements in DDL, DML. Here I want to show the new representation mode of explain command. Reading plans is critical for understanding and tuning the queries. And the existing solution looks cluttered, and the string representation of each operator can be very wide or even truncated. It becomes wider and wider every release because we add more information to each operator. And this release, we enhance it and with a new formatted mode, and also provide a capability to dump the plans to the files. You can see it becomes much easier to read and understand. So we show the tree structure at the beginning, and for each operator, we also show the details. In the future releases, we will add more useful information for each operators. So SQL compatibility is also super critical for workload migration from the other database system to Spark SQL. And we introduce ANSI store assignment policy for data for table insertion, and so exception on overflow and respect ANSI reserved keywords in SQL parser when the ANSI mode is on. Then we also switch a calendar to prolific Gregorian calendars. And also, this release enhance the building data source. For example, for packet data source, we can do the column pruning, filter push down for nested columns. And we also support the filter push down for CSV file. And this release also introduced a new binary data source and a new no-op data source. And this release keeps improving the data source v2 APIs by adding the new catalog capability and extend the compatibility. So I want to mention some breaking change here. Starting from this release, we only previewed a Spark with Scala 2.12 and deprecate the Python 2. In the download image, we previewed Spark with different Hive Hadoop combinations. By default, it will be the Hadoop 2.7 with the Hive 2.3 execution jars. And we also extend the support for different Hive metastore version from 0.12 to 3.1. You can always plug in your own external Hive metastore for these versions. Yeah, documentation improvement is the last exciting news I want to share with everyone. Previously, we do not have a web UI documentations. New Spark beginners are unable to understand, debug, analyze their queries or applications. Now we finally document them. You can see we explain each tab, the basic idea, basic information, what you should read, how to understand. Yeah, it's a pretty useful, to be honest, especially for the new reader, new users. And the SQL reference is another super critical for SQL users. Finally, we have our own SQL reference. You see the data types, identifiers, data rows, and yeah. And also now handling. We basically follow all the ANSI standard. You see there are many examples, description. Yeah, finally, previously only the developers know what happened. Now user can do it, can know it. And yes, and also the SQL syntax for the DDL, DML. Yeah, for example, here is a insert. Examples. And select. Select is very complicated, the most complicated one, and a different process. But here is having, and also limit, joins, and the functions. Like we separate a Scala function, built-in function, UDF, and in this list we also introduce our own datetime patterns. Yeah. Migration guide is also available for all the components in this release. When you upgrade your Spark application, you can check and understand the failure very well when you upgrade your applications. It will simplify your upgrade. If you look at what we did, it's planned all the breaking change. It's pretty useful. You can read it, yeah, a lot of details. Yeah. Today, I'm super excited to share this new feature here with everyone. They are just part of the release feature, and we resolve more than 3,400 JS. Yeah, so you'll find a lot of cool features. Please try them out. Try the Databricks runtime 7.0 beta. All these new features are already available. The community edition is for free. Yeah, you just create a cluster using a 7.0 beta. Very easy. Yeah, without the contribution by the whole community, it is impossible to deliver such a successful release. Thank you. Yeah, thank you for your contribution. Thank you, everyone. By the way, please attend our Spark AI Summit. We already have 30,000 registered attendees. It is free for the first time. There are 5 days with more than 200 sessions. You can learn data science, engineering, best practice for building the real world AI applications. Yeah. Okay, thank you.
Hi, everybody. Well, hey, thanks very much. This was a great presentation by Xiao. We are now on to the Q&A portion of this. So please, if you have any other questions, we did try to answer as many questions in the panel during the session, but obviously we couldn't get to all of them. So because of that, I do want to go ahead and now try to answer as many questions with Xiao as we can right now. But before we get right into it, I did want to call out, we had many questions concerning will the recording and slides be available? So again, we will go ahead and shortly after this session, we're going to go ahead and send out an email to everybody that's went ahead and registered for this event, and you're going to be able to get those recordings. Okay. Some additional quick callouts that we want to also have is that we have upcoming very soon is the book Learning Spark. Basically the second edition of the book. It's written by some of the members here from Databricks, including yours truly here. It'll include also references to Spark 3.0. And so be on the lookout for the book. It should be available by the end of the month. And the other important call out is if you haven't already done so, do join us at the Spark and AI Summit, which is between June 22nd and 26th. It's an awesome virtual event. We extended for 5 days with over 200 sessions, with a ton of pre-conference training as well. The reason we wanted to call that out is because the event is free. So please do join us. It'll be fun to have you guys join us for this session. Okay, Xiao, let's dive into some of these questions if you're ready for it. Are you ready, man?
Yes. Can you hear? Yeah.
All right. Cool. All right. Yes, I can. So let's do it. All right. So the first question is the usual community questions. It's the one that doesn't have a straight answer, but I figured I'd at least dive into right away. When will Spark 3.0 be released? Like, when's the GA for it? And I realize, by the way, that there's no real answer yet to it. So go give the approximate answer in the context, of course.
Yes, so we cannot guarantee the release date because this is being voted by the community. So I would suggest everyone to download and try our RC version. So maybe we will release another RC, so RC3 this week. So please try it very hard and see. If you hit any bug or any issue, please open a ticket and we'll address them as soon as possible.
Perfect. Yeah. So and if you're wondering, basically go ahead and join the Apache Spark users list. We actually go ahead and inform people about the latest updates, including these RC votes, for example, that the Xiao's referring to. So by all means, join us there as well. Okay. So the next question that we got is, where it actually has to do with the adaptive query execution portion of it, is where are the statistics obtained for the AQE?
Yeah, so this is a very good question. AQE, first, its statistics collection is very expensive. If we do it at the runtime, it's also very expensive. Fortunately, for tolerance, we materialize the data during the shuffle. So that's the place we get the statistics very cheaply. Yeah, so when we write the data in the shuffle stage, we get the statistics. Yeah, that's the place.
Perfect. Yeah, so I think there were some various questions about how to understand the underlying file system and statistics, how they come into play. All right. Some more recent questions were basically about really pandas and Python. So I'm going to sort of do a multi-part question here, but they're all interrelated. So the first question related to pandas UDFs is, do pandas UDAFs, aggregated functions, do they still exist in Spark 3.0? And will previous UDF implementations still be supported in Spark 3.0?
Yes. So yeah, this is another good question. The reason why we delay the Spark 3.0 release, the major problem is we want to avoid any breaking change. So that makes people hard to upgrade their Spark. And we audit all the API changes, and so to make sure all the previous user application can still work in most cases. For this specific question, like the pandas UDF and the previous pandas UDF interface, of course, we still support it. Yeah, and we also add many new UDF types And so please check our latest blog post about the pandas UDF. There's many examples you can read, you can check. Yeah.
Perfect, perfect. Thank you very much. Oh, I should have actually grouped this question with the previous one, so my apologies. When you're talking about AQE, when you're talking about like dynamically coalescing shuffle partitions, how does AQE determine the largest data size of the entire query execution, especially if the data set is columnar or compressed, things of that nature?
So when we read the data, so if we read the data from packet or C, so the data set is a columnar and compressed. But after we reading the data from the data source, so we can know we uncompress the data. The data processing inside the Spark is a row-based. So we can easily tell and know the size for each partition. Yeah. So then we decide, Spark will determine whether we should coalesce, reduce the number of partitions at the runtime.
Cool, thanks very much. And then actually, I did want to call out a quick question, basically that there was a quick question about where can I find documentation related to Spark 3.0 as it's currently not shown in the Apache Spark site, and that's correct. I just wanted to give a quick answer here. Basically, the quick call out is that when you are working with, once we do release Spark 3.0 and it becomes GA, then the documentation will go with it. Is there anything else that you think you would like to add to that, Xiao?
So in the RC voting, you can check there's a link to the documentation page. So so that is publicly accessible. Just join the user mailing list. Actually, Spark developer mailing list. So check the voting emails. There's a link. You can visit the new document.
Perfect, perfect. And so again, as Xiao was referring to, if you join the community, the Spark community, the distribution list, the developers and the users list, that's where we'll send out the emails concerning the voting of the current Spark RC release. I did notice some folks put some additional questions about when it's going to be. So as Xiao had called out, it'll be voted for soon. It'll be soon just because the community is actually the one that drives the schedule for this. But the next RC vote, it will be coming out soon. You'll be able to look at the documentation there as well. Okay. So let's jump into, let's still stay with partitioning. I'll jump back to UDFs afterwards. When it comes to the partitioning, there's a basic one still related to PySpark. Is there a difference between when you're using SQL versus data frame operations when you're doing performance? This is specific to PySpark. That like when I'm running a PySpark query, is there a difference between you running it in SQL or using a data frame? And actually, I'll add the addendum afterwards just because this one's probably long enough already. So.
So this is a very common question. So people always want to know the performance difference between like a PySpark and Scala, and there's many public blog posts that cover these topics. But in general, if you use like a data frame API we provided or SQL without any UDF, user-defined function, no difference, almost zero difference. The performance impact is very, very small, no matter which language you use. But if you want to run some like a Python functions, your defined Python functions or any pandas API, we have to serialize and deserialize the data from the JVM to Python. Then this will introduce actual cost overhead. But you can still use like a pandas UDF we provided for this purpose. That will largely reduce the overhead, but the overhead still exists. Yeah, so basically that's my answer.
Perfect. Well, then interrelated to that is in terms of feature-rich functionality, like which one's better versus SQL versus data frame functions? In other words, if you were to use SQL versus data frame operation, which one actually has more features in relation to each other?
So SQL API and the data frame API. Performance-wise, no difference. But the API level, they have a different way to represent your queries. Normally, SQL API, so we follow the standard. So that's why it's not easy to, or not flexible to do very complex, very complex queries. But different APIs, we added many very flexible, easy to use API for your applications. So normally, I personally like using the different APIs. Yeah, but performance-wise, no difference. Yeah.
Exactly. Perfect. Okay. So there is another question which I'll take a chance to answer, so that way you can take a little bit of a break. Is it possible for Python to become the reference language for developing in Apache Spark? It's a great question because there's a lot of folks in the Apache Spark community that really want to use Python. And so you'll notice from today's session that there's a massive focus for us to go ahead and talk about it within the context of SQL and all those functions that are added as part of Spark 3.0, and also Python, especially with the callouts for the pandas UDFs, the vectorized UDFs, and also Qualys, which we didn't really mention much here today. And so I wouldn't say it would become the reference language insofar that the development work itself is very much done in Scala per se, okay? But in terms of the usability and how people use it, obviously Scala is a first-class language, but as you can quickly tell, SQL and Python are being heavily used within Apache Spark, where many people who are using Apache Spark now are in fact actually just doing it with SQL or Python. Now, typically the SQL from a data engineer or relational database type background, and Python from the standpoint of data science. Now, there's a lot of intermixing, so don't get me wrong, we're not going to always stick to those rule of thumbs, but that's the general context or general gist. Hey, Xiao, is there anything else that I forgot to add in that?
No, that's good enough. Yeah, pretty good. Yeah.
Cool. Always good to have your approval, my friend. All right, let's go back to the fun. Let's go back to the fun questions. Back to dynamic partition pruning. We got a lot of good questions on that. So let's just dive into this a little bit. How applicable is dynamic partition pruning? Like, is it only for star schemas? Does it work for all different join types? Like, yeah, let's just start with that.
Yeah. So this is a very detailed question. It's very hard to give very clear answer. First is it is not only for staff schema. Staff schema is just a very typical usage scenario, especially for TPCS. We can get a very good performance number because of their features. The major reason is TPCS query benchmark is the underlying database is using the star schema. So that's why it got very good performance enhancement. But in general, it is applicable to inner join and the left semi-join if the partition on the left side, and the left outer join partition on the right side, or right outer join partition on the left side. It's very hard to remember. And we also have like multiple other conditions. This basically is just to avoid to introduce like some regressions. We are very conservative. Yeah.
Excellent. And so,
yeah.
Yes.
Yeah, sure.
And so there is a little bit of a question that's actually related to it, to this dynamic partition pruning. In this case, this is specific to Z ordering, which is part of the Databricks managed Delta Lake service. and dynamic partition pruning. And the question related to this is that are Z ordering and dynamic partition pruning, are they complementary or are they considered as orthogonal to each other?
Data lake is external data source, so they are not affected by each other. So they are complementary. That means you can use apply both optimization at the same time. So they have a totally independent conditions for applicability.
Perfect. Thank you very much. Yeah, perfect. No, there were various people asking that question, so I wanted to make sure that we had that answered right away. That was all. So, okay. Actually, I'm going to take a little break from questions because there was a couple of questions about the Spark and AI Summit, so I did want to take a break to answer that question. And let me move the slide back to that just in case you want to know more. So the questions were basically, hey, I registered online, but I didn't receive any links about the training session. So if you want to sign up for training for the Spark and AI Summit, when you register, there's actually a bunch of checkboxes in the site that allows you to choose which sessions you want to go ahead and attend, including the training session. So if you're not able to go ahead, if you've already registered, I would just go back to the site, re-register, and then be able to choose the dates that, the sessions that you care about. Okay, so I just want to really call that out real fast. Okay. So, hey, Xiao, there's a really good question that I want to, that's also common here, is why isn't, for example, with Spark 3.0, AQE not enabled by default?
Yeah, so this is another good question. So currently in the Spark community development, we are very conservative. We don't want to turn on the new features by default in the first release. We know the first release normally it means some unknown issue or some some bugs even. So we want to first let more people try it. When it becomes stable and we fix all the reported issues, then we'll turn it on by default. But in current stage, we really want the community to try it and leave some feedbacks. For example, in some scenario, if you hit the performance regressions, please let us know. We want to make sure we can automatically reduce the overhead or even do not turn on the AQE in this specific case. Yeah, that's my answer. Yeah.
Perfect. Well then, related to AQE as well, so which is, we had a couple questions like this, which I did want to call out. Hey, should we now forget all about our optimization tricks that we've been doing with Spark? Like, for the call as for newbies, doing something, AQE is awesome, right? Like, that's great to have. But if you're a more experienced Spark developer, right, does it mean basically all those optimization tricks that I had before should just go out the window? I should just let AQE solve everything? Is this the magic pill?
Hopefully, eventually we can simplify the the Spark a lot by AQE. But in the current stage, this is just the beginning. And it does not solve all the problem. Let me give you some very quick examples. For example, AQE can automatically convert the submerged run to broadcast hash run, but we only can get the statistics after the shuffle. So that means shuffle is still needed. But broadcast hash run, ideally, it does not require any shuffle. So you will see the performance difference. Even you turn down the AQE, even your submerged run is converted to the broadcast hash run, but you might still need to use that broadcast hash run hint to avoid the shuffle. And also wireless. So currently we only can reduce the number of partitions, but we cannot automatically increase the number of partitions by A to E. And data still join, yes, so that solve many still issue, but we still have a lot of still issue. It does not solve. For example, aggregation, or in some cases, the join, yeah, so the still join still not solved perfectly. Yeah, so this has to be case by case. And in the long term, in the future releases, we'll continue this direction, and we'll apply more adaptive optimization rules. And yeah, so yeah, that's my answer. Yeah.
Perfect. So, hey, we only have a couple minutes left, so I did want to go ahead and we'll probably be able to answer one or two more questions. I did want to answer one question right away, which is to help out. It's also a common theme for some of the questions that were asked is like, hey, which is basically if you're moving to a Spark-based application and you're building from a traditional ETL tool, how do you choose the path on selecting a programming language between Scala and Python? And there's no straightforward answer to this because it really depends on the people you have and what you're trying to do. Traditionally, you would go ahead and use Scala and SQL for data engineering, and you would use Python and SQL for data science, and then SQL for data analysis. General rule of thumb. I want to be very clear about that. But as you can tell, especially from today's session, especially from Spark 3.0, the reality is, you can do a heck of a lot more in SQL. You can do a lot more in Python, and it's not like Scala can't do data science either. Okay, so it really is a matter of like, yes, you can start with these general rule of thumbs, but I also would want to take into account the people you have, right? If you happen to have a lot of Python experts, then you can probably just get away with doing everything in Python, and that's perfectly fine. Again, the quick call-outs that Xiao had done about the UDFs, the Python UDFs with hints, these are excellent call-outs to improve the performance even more still. But that's probably as close to an answer as I can give. Xiao, I don't know if there's anything else you'd like to add to this as well.
Yeah, that's good. Yeah.
Cool. All right. Well, then the final question, actually, we're going to just do, just because there was a ton of questions about GPUs. Okay. So I did want to go ahead and just ask the questions like, for the UDFs that you're basically using it, does it help to improve for your deep learning inference on multiple clusters with one or multiple GPUs per worker when you're utilizing basically these Panda UDFs?
Yeah, so first is I have to say I'm not a GPU expert. I'm not the expert in these areas, but I can answer in some cases, especially our new Pandas UDF, we provide the iterator to iterator, so that will you can easily write a pipeline, and also you can use it when your initialization cost is very high for the Pandas UDF. So that is a very good use case. But in general, the GPU scheduling, so this is very specific to your applications. You can use it, schedule your application to a specific GPU resources in the application level. In the future, we will make it more flexible. Yeah. I think we will have in this Spark Summit, there's a dedicated section by the NVIDIA experts. So they will talk about how to use Spark GPU scheduling. Yeah.
Yes, that's exactly it. That was a great call I was just about to make. So, okay, it is almost the top of the hour. I did want to finish up now. You've asked a lot of really good questions, and I'm sorry that we weren't necessarily able to answer all of them, but we do have a recording of all the questions, and due to the sheer number of them, Xiao and I will probably spend time to write a follow-up blog to answer some of these key questions, just because there's some really good ones that we weren't able to answer, so apologies for that. A couple final little call-outs. Number one, the Learning Spark book, second edition, will be out very soon. You can get the pre-release if you go to the O'Reilly website. or you can pre-order it on any site, but you can look at the pre-release right now. And again, the book is scheduled to come out in the next few weeks. And finally, again, we want to end with please join us at Spark and AI Summit. We both will be there to answer questions live as well, just like we're doing now. We both have sessions. We ask questions. So definitely please join us, and whether it's for the sessions or for the training. And so without further ado, I want to thank Xiao for this awesome session. Thank you very much for your time to answer all these questions. And thank you, the audience, for going ahead and coming and spending your time with us.